Hello, so today we are going to do problems from this week's weekly contests. So this is this week's weekly contest 391, and the second problem is water bottle 2. So let's see what the problem is asking us to do. So we have some number of bottles and we have some exchange number, okay? And essentially the number of bottles represents the bottles that are full of water that we start with. And in one operation, we can do one of two things. We can either drink all the full water bottles, and once we do that, they will become empty bottles. And then the second operation we can do is exchange, but we can only exchange this value. So for example, here it's the first example, it's 6. We can only exchange 6 empty bottles with one full bottle. One full water bottle, okay? But the other caveat is that once we exchange it, we increment the number of exchange, so that next time we need more by 1, okay? So that's the idea here. And the goal is to return the maximum number of overall water bottles we can drink with this setup here, with these operations. I think the tables here are very helpful in explaining what the problem is. So let's just look at the first example here. We have 13, then exchange number is 6, and so we initially start with 13. So let's say we drink all of them, and now we have 13 empty bottles. The exchange value is 6. So let's exchange, basically the exchange value is 6 means we need 6 empty bottles to get 1 full bottle. So let's take the first 6, get 1 full bottle, and now we have 7 remaining. Let's take, now remember, each time after we exchange, we need to increment by 1. So we increment the exchange value, number exchanged by 1, so we have 7. And now we take this 7, we exchange it by 1 full bottle, right? And so now we have 2 full bottles, and so we drink these 2. So now we drank 13 here, and then these 2, so now we drank 15 overall, and that's what we have here, okay? So that's the idea. Now the constraints are very small, right? 100. So this tells you we can just simulate exactly what we are being asked, just implement exactly what we are asked here. So let's see what it looks like, and this table helps quite a lot with implementing here. So let's see what we need to do. We need to know the empty bottles, right? We need full bottles, we need the number of exchange, and need the total that we drink, okay? So the total is just the total number that we drink. We need the full bottles, we need the empty bottles, okay? So let's do each one of them. Total, let's start out as 0. Full bottles, let's start out at just the initial number. And then the empty bottles, initially we don't have any, 0. And so we need to keep going as long as we have full bottles, we should drink them, right? But the other thing is, if we have empty bottles that we can still exchange, then we should continue. But what does it mean, still exchange? Well, we need the number of empty bottles to at least be bigger or equal to the number to the exchange value, because let's say if we have 2 empty bottles and the exchange is 4, well, we should stop, because we will never be able to, if end full bottle is 0, we should stop, because we'll never be able to exchange these with this to get a full bottle, right? And so we need either the full bottles is bigger than 0, so there is still more to drink, or the empty bottles needs to be bigger or equal to the number of exchange. Because if this is the case, that means we can exchange the same num exchange empty bottles with 1 full bottle, okay? Okay, so the first thing, let's just consume the full bottles. The first thing we do, and so consuming means we increment our total by the number of full bottles that we have. But once we do that, we should set them to 0. But also before that, remember, each bottle we drink becomes empty, and so we need empty bottles to be incremented by the number of full bottles that we consumed here, okay? And then once we do that, we need to check if we have, so what I'm choosing here is to do multiple operations in the same while loop iteration. So this here basically just consume full bottles. And then here, what we need to do, what we'll do is use empty bottles to exchange with full bottles. So what do we need to use empty bottles? Well, we need the empty bottles to be bigger or equal than the number exchanged, because otherwise we can't exchange. That's the first thing. Okay, but also we need full bottles to be equal to 0, because if it's not, it will be equal to 0 no matter what, actually, because we set it here. Okay, and so when we do this, that means we can exchange. So the operation says each time we exchange once, and then increase the num exchange by 1. So we need to increase this by 1, but we need to subtract minus the num exchange, and this gets us only 1 full bottle. So we need to increment the number of full bottles by 1. Okay, so we do that here, because this exchange here exchange with 1 bottle, full bottle, and so we increment it here. That's pretty much it. We can return at the end the total that we were able to get. So very simple, just exactly doing the iterations that we are asked to do. So let's see, run this, looks good. Let's submit, looks good. Okay, now in terms of time complexity, it's going to be at most the number of full bottles, right? Because that's how many we can convert to empty, that's how many we can exchange. Worst case is that when num exchange starts as 1, for example. But this is too wordy, uses a lot of variables, so let's see if we can simplify it just as an exercise here. Well, the first thing you notice is we don't really need the full bottles, right? We can just keep track of the empty bottles. Why? Because, let me show you. Instead of initializing total to 0, we can just initialize it to the number of bottles, because we know these are the full water bottles. We will consume them in the beginning anyway, okay? And so we don't need this either. We just keep doing that. And here we need to total, we just need to we already set up the initial number of bottles, so here we only need to increment each time we do an exchange. Instead of waiting till next time, we can just do it here. Each time we do an exchange, we increment by 1 instead of doing full bottles, because we do an exchange to get a full bottle that we consume. So instead of adding it to full bottle variables and then consuming it, we just consume it right away here. Okay, so this consumes exchanged full 1 full bottle that we just exchanged it here. Okay, so now we don't need this because we already did this one, and for the incrementing for each exchange we do it here. We still need to add, we don't have full bottles, so let's think about what we need to do here. And this is the same as our while condition, this if here, so we don't need it. Okay. Okay, so let's see here. What do we need? We still need to keep this. But the other problem is that, so let's just change this notation a little bit. Okay, so the other problem is we consume this exchanged 1 full bottle, so it will become empty, right? And so we need to condense these operations. So now we need to remove this, and we need to, so the +1 is from the consumed full bottle that we just exchanged, right? Why is that? Because let's see here. So let's see what happens here. You can see here, for example, this one that we converted from 6 empty bottles. Okay, you can see here that we end up adding it to the empty bottle at the end. So instead of waiting until like accumulating the full bottles and then adding it, we can just, when we got it here, we add it here to the empty bottles. This is here. We add 14. And then when we get here, we have only 1, and we add it, and we have 15. Okay, so at each iteration, we condense the operations, and we do them, as many of them as we can at once. That simplifies the code a little bit. And if we run this, looks like we just have a problem here. Okay, let's submit. and this passes. Okay. Yeah, so I think this is simple enough. No need to do further. That will only complicate it. But yeah, that's pretty much it. A relatively easy problem, I think. Thanks for watching, and see you on the next one. Bye.